Hey, it's your old pal, Dr. Steve, and welcome to the SARS-CoV-2 COVID-19 updated situation report for May 17th, 2020. This is the 8th in a weekly series. Previous episodes are available and have general information about the current pandemic that are not covered on a weekly basis. Okay, so let's get started with the statistics that we're following right now. These are from covid.stoutlabs.com. World total, 4.5 million cases, with the United States having about 25% of those. And so the top four are now USA, Russia, United Kingdom, and Brazil, with Spain and Italy close behind. But if we look at, that's total cases. If we look at cases per 100,000, the United States is 443 cases per 100,000 people. And these ones at the very top are really more related to small numbers. You know, San Marino's got 653 cases, but a very small population. So let's get down here to Iceland, which has 528 cases per 100,000 compared to our 443. So they're in the same ballpark. Now, when we look at deaths per 100,000, that's this column here, we can see the United States is about 26 deaths per 100,000. And Italy is at 52, so it's really just about double. The United Kingdom at 50, France at 42, Sweden, which has been touted as one of the countries that has remained open to a certain extent, is right at 36. So they've got 10 more per 100,000 than the United States at this point. Not sure where these numbers are coming from or what the relevance is, but it is interesting. And hopefully as time goes on, we'll know why Italy, for example, has twice as many deaths per 100,000 population than the United States does. If we look at it graphically, here we are comparing by country cases, and I just included the top four. So we have the United States, United Kingdom, Russia, and Brazil. But if we look at, and we're far ahead of everyone else, but if we look at cases per 100,000, the United States is still in the lead, with the UK right behind, and Russia and Brazil significantly decreased from there. But if you look at deaths per 100,000, the United Kingdom is tops the field at 50 deaths per 100,000, the United States at 26, and then Russia 1.7. I just wonder if that's a reporting issue. So we'll see as time goes on. Several states have reopened, quote unquote. This just means that commercial entities have opened and with some social distancing rules applied, and Georgia was one of the first. And you can see that the 20-day smooth moving average, which is the red line in the middle, or the simple moving average, still continuing to decline. Now, on April 30th, shelter-in-place rules in Georgia expired, and you would expect to see some increase in these numbers if things were not going well. Now, you can look at the new hospitalizations. If you look at May 16th, you see that huge spike. But we've seen huge spikes before the shelter-in-place expired on April 27th, if you look over toward the left of that line. So these may be just reporting issues where data sits on someone's desk and then they all of a sudden just dump it all at once, and then we see these numbers. So it'll be very interesting over the next week, particularly in the next 2 to 3 weeks, whether we see an increase. And if we do not, then we could consider this reopening to be relatively successful. If you look at new cases in Georgia, they've pretty much leveled off. So increasing people's exposure to the outside world does not seem to have increased the number of cases significantly, if at all. Actually, that trend line is trending slightly downward. So we will, again, remember it takes from the day people are exposed around 5 days for average to develop symptoms, and then by 14 days, 96% of people have developed symptoms. So this is the 17th, and so we're 17, 18 days after reopening in Georgia, and still have not seen a big peak. So hopefully that trend will continue. We'd like to see this trend downward. Now, when you see cases leveling off like that, what that means is that the R0 is approximately 1. So if the cases are going up geometrically, the R0 is greater than 1. If they're going up linearly, in other words, the same number of cases every day, the R0 is approximately 1. And then if they're declining, the R0 is less than 1. And if you don't know what I'm talking about, go back and watch the COVID SITREP just previous to this one where we talked about herd immunity. All right, let's look at testing. What is the asymptomatic fraction? I've heard things from 80% down to 3%. Who knows? So we should look at actual data. So the Diamond Princess, 46% of those patients on that boat, or on those passengers on the boat who tested positive for SARS-CoV-2 infection were asymptomatic. On the Thomas Jefferson, 60% were asymptomatic. Those were young, healthy military folk. New York Presbyterian and several other sites in New York City did a mass screening of everyone coming into the labor and delivery suite. 15% of their patients tested positive, and of those, 88% were asymptomatic. And those were young, healthy women in an area of high prevalence, so they cautioned in this letter to the editor, which is not a peer-reviewed, double-blind, placebo-controlled study. I mean, you couldn't do that anyway. But it's a population study, that these results are not generalizable to the general public. Here it is in graphical form. 182 patients were negative, the vast majority, which goes along with the statement I made early on in this pandemic that most people will not get it, and most of those who do get it will not die. 29 patients were SARS-CoV-2 positive but were asymptomatic. They never had any symptoms. Now, they didn't say how they determined their positivity, whether they did a PCR test, the polymerase chain reaction, which is pretty specific for this particular virus, or did they just do an antibody test? And the antibody test, remember, can give us false high rates of immunity because they can cross-react with other coronaviruses. So the way to tell if your particular test is a good test, if you are a lab that's producing one of these tests, is to test it against blood that was drawn, say, 6 months before this pandemic hit in China. Then you know there's no chance that any of those people had SARS-CoV-2. And if any of those turn up positive, then you know that your test has some problems with regard to being specific for this particular virus. Let's look at Iceland. Iceland has tested about 166 people per 1,000 population, which is about 16.6% of their population. Total cases were 1,802, approximately 5 per 1,000. And then their estimated 0.6% of the population were silent carriers, aka asymptomatic carriers. Now, I got these from two different places because I can't seem to find one data set that says, here's how many people who were symptomatic, here's how many we tested were asymptomatic, and then you can put the numbers together. So I got this from two different data sets. So 0.6% of the population translates out to about 2,160 people who are asymptomatic carriers. And that would give a 54% asymptomatic rate. So let's just assume, to ballpark this, that the asymptomatic fraction is 0.5. We have 1.46 million known cases. Therefore, if there's one asymptomatic person for every symptomatic person, we would have at least 2.52 presumed total cases. And that works out to about 0.8% of the total population. So still less than 1% of the people. Let's look at some new vaccine trials. The federal government unveiled Operation Warp Speed, which will have 14 vaccine candidates with an early 2021 goal. But in the meantime, Pfizer is expected to roll out expanded vaccine trials by September. And if there's no issues, everything goes according to plan and everything goes perfectly, they should have wide release vaccine for everybody to use by October. So Pfizer did a phase 1 trial March 5th in Germany, and they're accelerating this. They're testing 4 versions of the vaccine. They'll see which one is the safest and the most effective. Hopefully, that'll be in one vaccine, not 2 different ones. And then phase 2 is going to start in June, and then phase 3 in September with a commercial rollout planned for October. Now, one way to accelerate these vaccine trials is to do a challenged vaccine trial. And so there's a regular population trial where you just give 5,000 people the vaccine, and then you follow them over time and see if fewer of those get infected compared to the general public, or if fewer of those get sick or end up in the hospital, because maybe you get infected but you just don't get sick. Now, there's another way to do this, which is a challenge trial. In the challenge trial, you give people the vaccine, you have them come back a week later, and then you spray COVID-19 up their nose. Now, you have to do this with volunteers, and they have to be selected properly so that they're not at too high risk. And then you determine whether they were protected. Now, that can speed up the phases of these trials by orders of magnitude. I haven't seen any vaccine manufacturer that has so far deigned to try this, but it would certainly speed things up, and I would highly encourage it. And I would volunteer. Let's look at some drugs. We've got blocking antibodies. Sorrento, Eli Lilly, and Regeneron were all working on antibody therapy. And there was a big headline that Sorrento announced an antibody that blocks 100% of SARS-CoV-2, but it was in vitro. They didn't put that in the headline. In vitro means in the test tube. This antibody has not been tested in animals yet. Therefore, it's certainly not been tested in humans yet, so it is months away from phase 1 trials. This is not a new technology. Making monoclonal antibodies against some antigen in the body is used in cancer therapy all the time. And any drug that you see that has MAB at the end is a monoclonal antibody. So there are those for rheumatoid arthritis, psoriatic arthritis, cancer, all kinds of stuff. So this would just be one for this particular virus. So just looking at this on the left side of the screen, you see your virus, and those little red dots are the things that will attach to whatever part of the body. We'll call that the virus receptor site. Those receptor sites were not designed for that virus, but they were there, and the virus is going to now use them. And when it attaches to those receptor sites, then it injects its DNA or RNA, depending on the type of virus, into the cell, and then reproduces itself, and then makes tons of copies that then burst out of the cell and do this process over and over again. Now, if you inject somebody with antibodies to that virus, and you can see in the middle, the green little Y things are IgG antibodies, and they will attach to those viral antigen sites and block them, if you look on the right side, from attaching to the viral receptor. And this does not confer long-lasting immunity, but these antibodies will stay in the body for 2 months to 4 months. And, of course, not all of the viruses will be blocked by these antibodies. So there will be a few that sneak through or just didn't encounter those antibodies in the bloodstream, and they will encounter the body's immune system. Macrophage will envelop them and then pass the signal to the B cells, which then produce antibodies. So hopefully, when we treat somebody this way, they will still produce their own natural immunity. It just gives them a leg up, and it boosts their immunity artificially in the short term. It's very exciting. So viruses have to have protease enzymes to reproduce. They're these enzymes that sort of, when they're putting themselves together, that's sort of the signal or the enzyme will clip off the end, so it's done. You know, if you're making string and you're making shoelaces, you have to measure them to a certain length and then cut them off. Otherwise, you have a shoelace that's 2 miles long. It's stupid. So they have to have these protease enzymes to allow that to happen. And the great thing is these particular enzymes are not found in humans, so they're a great target for antiviral medications. There is a new protease inhibitor called 11A that's completed mouse trials. Human trials are pending, but it's been very successful. But they haven't even started phase 1 yet, so we're looking at months and months away. So UCSF decided, let's take a different approach. They mapped all the human proteins that SARS-CoV-2 has to interact with to reproduce, and then they looked at drugs that were already on the market or already at least in the pipeline that target those particular proteins. And they yielded antibiotics. They didn't say which ones. I'm assuming one of them is azithromycin. Antimalarials, they also didn't say which ones, but I'm assuming one of them was hydroxychloroquine. But there was an anti-cancer drug called PB28. Now, PB28 was 20 times more potent than hydroxychloroquine in deactivating SARS-CoV-2 in vitro, so in the test tube. So in vivo studies are pending. So let's look at some stuff that we can maybe a little more practical that maybe we could use right now. So there's a 3-drug combination that was used. It included interferon beta-1b, which is used in multiple sclerosis, and it's a very potent anti-inflammatory. Lopinavir ritonavir, which we talked about before, which was not very effective in preventing progression of the coronavirus disease. But it's a drug that's used in HIV therapy. And then ribavirin, which is an oral hepatitis C drug. And when these 3 were given together, viral clearance was found in 50% of the time compared to the control, and the control was lopinavir and ritonavir alone. So what's interesting to me is it's totally unknown whether lopinavir, ritonavir is even required for this. Maybe it's just the interferon and or the ribavirin. How would we know? Well, we're going to have to do another study that compares interferon beta-1b plus ribavirin against interferon beta-1b with lopinavir, ritonavir, and ribavirin. And then if that shows something, well, then we need to do one looking at interferon versus ribavirin. Maybe it's just the ribavirin. Wouldn't that be awesome? You could just take a pill and go on your merry way. So we shall see. These studies are ongoing, but this 3-drug combo, all these things are on the market right now. We could use that tomorrow. And it will be used. I'm still very interested in Favipiravir, hoping that this proves to be the drug that will allow us to go back to work while we're waiting for a vaccine. There are phase 2 trials going on in Massachusetts that are recruiting now. If you're interested in getting into one of those, go to clinicaltrials.gov, put in Favipiravir, and see what comes up. If there's something that you can get into, go for it. It's a tablet. It can be given in the outpatient setting. Cannot be used in pregnant women because it's suspected to be teratogenic, meaning that it could cause birth defects. It's not been tested in pregnant women. All right. So in the meantime, stay healthy, isolate, and if you're going to do something out in the real world, if your state is reemerging, please be smart. Still social isolate and social distance. And remember, the South Korean hotspot started with one person being infected, going to a church where no one was social distancing and singing in the choir and giving it to like 100, 150 people. Started a whole secondary hotspot. So we want to be very careful. Wash your hands. Soap is greater than gel. Wear the cloth covering over your face when social distancing is difficult, and just stay healthy. Just don't do anything stupid. Check out our Twitter at Weird Medicine. Check out the podcast at riotcats.com/weirdmedicine or SiriusXM Faction Talk on Demand, or Saturday nights at 8 p.m. Eastern on Channel 103 Faction Talk, or 5 p.m. Sundays on Faction Talk as well. We're also on iTunes and anywhere you hear podcasts. So until next time, see you next week. for the Weird Medicine COVID-19 Situation Report. Stay healthy, everybody.